Assalamu alaikum and welcome to the presentation of the group project of Group 3, Hand Crank Mechanical Energy to Electrical Energy Storage System. As the name suggests, our device converts the mechanical energy applied in the crank to electrical energy, which can be used for running electrical devices. It also stores the produced electrical energy, which can be used later. Here are the equipments we use to make this device. 12-volt 300 RPM DC motor, crank, breadboard, jumper wires, diodes 1N4007, IC 7805, LED 1.5 volt, zip tie 5.5 volt 1 farad supercapacitors 4 pieces, and switches. This is our device setup. And this is a simplified diagram of the setup. The device has several components, namely a DC generator, a bridge rectifier, a regulator IC, capacitor bank, and a protection diode, which all serve different purposes, and together they accomplish the function of producing, transmitting, and storing electricity. Let's look at the different components of the device. At one end, we have a 300 RPM 12-volt DC motor, which is being used as our DC generator. The rating suggests that it can produce 12-volt electromotive force when rotated at 300 RPM speed, and we shall demonstrate that in the video of the operation of the device. This DC generator produces and then supplies electricity to the capacitor bank through the bridge rectifier and the voltage regulator IC. Between the DC generator and the capacitor bank is a bridge rectifier. This ensures that regardless of the direction of rotation of the DC generator crank, the developed electromotive force will always be clockwise. So, if we change the direction of rotation of the crank, the direction of current in the circuit will not be reversed and the generator will always supply power and not consume power. Our DC generator can generate 12-volt electromotive force, but considering the load used in the device, we have to restrict the voltage supplied to 5 volt. For this purpose, we use the voltage regulator IC 7805, which restricts the electromotive force supplied from the DC generator through the bridge rectifier to 5 volt at all times. This prevents the burning out of the LEDs used as load. The regulated voltage through the IC is then applied to this 4 farad capacitor bank, which is made up of 4 5.5 volt 1 farad supercapacitors that are connected in parallel. The capacitor bank stores the electrical energy from the DC generator for later use. Connecting the voltage regulator IC to the capacitor bank is a 1N4007 diode, which ensures that electric current flows from the IC to the capacitor bank and not vice versa. So, the capacitors can discharge only to the direction of the load and charge only from the direction of the generator. Lastly, we have three 1.5 volt LEDs connected in parallel to act as loads to the capacitor bank discharge. Let's now look at the actual operation of the device. Here we can see that the DC generator can produce nearly 12 volts when rotated by hand. The capacitors are charged through the regulator IC, so the voltages stay under 5 volts. As the load is connected to the capacitor bank, the capacitors start discharging and the LEDs light up. We can see that the voltage gradually drops in the capacitor banks as it discharges. So, the device runs successfully. Although the device accomplishes its purpose of generating, storing, and supplying DC voltage, there is room for improvement through which the device can function more efficiently. For example, a crank handle could have been attached to the prime mover of the DC generator, which could have made the rotating of the mover more convenient. A tachometer could be attached to the prime mover as well, from which we could keep track of the rotating speed of the mover so that it does not exceed the rated speed by much and avoid damaging the motor. Also, a switch could have been added in the circuit on the discharging end of the capacitor bank as it connects to the load, so that the connecting wires need not be disconnected and connected manually from the breadboard. Overall, the entire setup could have been done in a more compact structuring so that the device could have better mobility and have smaller footprint. With some adjustment, this sort of DC generator module can be used as an economic alternative to batteries in situations where a prime mover is readily available, such as to power LEDs on a bicycle from the rotation of its wheels. That was all about our project. This project is an effort from the members of Group 3 in Section C1 with student IDs from 1806143 to 1806149. We would like to thank our course teachers for their kind cooperation and guidance regarding the project and throughout the course. Please do acknowledge our sincere gratitude. With that, I conclude this presentation. Thank you for your patience.